Hello everyone, this is lesson 17 and today we're going to talk about servo motors. So to start, what is a servo motor? A servo is a type of geared motor that can only rotate 180 degrees. It is controlled by sending electrical pulses from your Arduino R3 board, and these pulses tell the servo what position it should move to. So this requires a digital source and PWM. Oh yeah, this is 180 degrees it should move to. And then the servo has 3 wires, of which the brown one is the ground wire and should be connected to the ground port on the Uno board. The red one is the power wire and should be connected to the 5-volt port. And the orange one is a signal wire and should be connected to the digital ports. So let's show our servo motor. So this is what it looks like: a micro servo SG90, which is 9 grams, and then this is its wire, and then here's the ports. As you can see, there is a brown wire, a red wire, and a yellow wire. So the brown wire is ground, red wire is power, and yellow wire is the signal wire, or the wire that tells the servo motor how much position it should move the arm. So this is the servo motor. It has an arm. Alright, so let's talk about how it works. In other words, the principle. So let's search up servo motor SG90 principle. Alright, let's go into the Sun Founder. This is Arduino and Raspberry. Alright, so the principle, there's a neat diagram here. The inside, there's 3 wires, the brown, red, and yellow. Ours is brown, red, and orangey. Alright, but these are the 3 wires that go into the servo. It supplies a power, a ground to close the circuit, and a signal. The signal goes right to the board, and then it goes into the DC motor, and the DC motor spins around, and it goes into the gear system, and the gear system slows down the rotation, and then the rotation can be seen through the servo horn, or the arms if you will. And then the potentiometer here is basically like a resistor, but it can change the resistor amount, and the embedded board or chip reads the resistance amount from the potentiometer and determines what angle the arms or the servo horn is at. And then it can calculate how much it needs to change the DC motor to make the servo horn or the arms turn to the desired degree. And by the way, the servo can turn from 0 to 180 degrees. Alright, and for our experiment, this is going to be our schematic. Our schematic is quite simple, like this. So there's a ground and a 5-volt positive terminal, and let's connect to digital pin number 9, and this will give us our signal. Alright, and let's also, so if you guys want to read this website on your own, you can also do that. here's a link. Alright, so let's build this circuit. So for now we don't need the breadboard, let's take it away. And then, so in order to connect the servo motor to the Uno board, we need 3 lines. A black line for the ground, a blue line for the signal, and then a red line for the positive. So let's connect the ground first. So it's connected to this. And then the other end, let's connect it to the ground here. And then let's connect the 5-volt positive energy or power to the middle, because this is the red line. Connect this end to the 5-volt here. And then the signal line, which we're going to use a blue line, really distinct in color. So we're going to put this in here any day now. Alright, into here. And then we said pin number 9, so this one here, like this. Alright, so this is our schematic diagram. This is all we need. Alright, and then now let's create some code. So let's create a new sketch. And we don't need this one anymore, don't save it. Alright, so this is our Arduino IDE. So before you can manipulate how the servo motor changes its arm, first we must include a library that does the servo motor for us, manages it. So let's go into our libraries and then look for the servo.zip and let's select this. We already imported the library once, so we can overwrite the existing one. It's the same thing. So this is the library, and now we need to make sure that we include this library. So hashtag include servo.h, like this, and no need for a semicolon at the end because this is an library inclusion. Alright, and then we can make an object of the servo class. Let's call it myServo. So our servo will be able to be controlled through this object called myServo. It's kind of like a variable, but not the exact same. And then now we can make an integer variable called position. Let's say 0 degrees. And then in the setup, we need to define the myServo. So myServo.attach. This means where the signal pin is coming from. And in our case, it's pin number 9, like this. And then we can use another line. That's myServo.write. Now this changes the position for the arm on the servo motor. And for example, we're going to use our position variable here. So we can write position in here like this. And so our arm should move to position 0. Alright, so let's come here. We can plug in our board and then make sure this is in view. We can make sure, alright, we can upload this. So this is at 0 degrees. We can use a clip kind of to clip our servo upright. I don't want to be holding it for the whole class. Like this, using a clip. And then, so this is 0 degrees. Let's assume that this is a horizontal line. And then as it turns, it will be more and more towards the 180 degrees mark. So now it's at 0 degrees. Let's change this up into, let's say 45. So it changes into 45 degrees. And then we can increase it by another 45 into, let's say, 90 degrees. Alright, so this is upright 90 degrees. And then the maximum it can go to is 180 degrees. So it will turn from here all the way to here. Alright, so now we know that 180 degrees points this way and 0 degrees points this way. So now this is a very ineffective way of changing the position, having to change the software once at a time. And we can use a for loop instead that allows us to change the position from 0 degrees to 180 degrees. So we can write here a for loop where position starts at 0, and then every single time it can increase by 180 degrees. Increase until it is to 180 degrees. And then every single time we add 1 onto the position. So it starts at 1, 2, 3, 4, 5, and all the way to 180 degrees. And then at every single step of 1 degree, we can update our servo to our position and then delay 15 seconds. So this delay is to let the servo reach the position before we move on to the next degree of iteration. And let's say at the start it's at 0 degrees. Alright, so now let's run this. So as you can see, it moved from 0 degrees to 180 degrees. So over here, let's let it delay for a little bit before we start the for loop. Let's let it delay for, let's say, 25 milliseconds. We can run this again. Alright, and then we want to make it go back now. So it moved from 0 degrees to 180. Now we want it to go from 180 all the way back to 0. So we can use another for loop. Position equals 180 degrees. And then every single time we can -1 until it reaches 0. Equals 1. Alright. And then my servo.write position delay 15 seconds. This is the exact same thing as inside of the last one, so I should not need to explain it again. Alright, so let's run this. So it moves from 0 degrees to 180 and then back from 180 to 0. So now this is a single loop of this, and now that I say it's in a loop, we can of course move all of our for loops down into our loop in here. And now it will go from 0 degrees to 100, and then from 180 back to 0 to 180, and keep on going back and forth. Alright, so we no longer need the position at the start. Alright. Alright, let's run this. So it starts at 0, and then goes all the way to 180 and back. 0 to 180 and 180 back to 0. Alright, so now that we know how to make it smoothly run from one side to the other, we can also make random jumps from one position to a random position in time. Alright, so that's what we're going to do next. So let's take away the power, and then we are going to add a button on the breadboard, and that way we can select when we can make a new random time. So here's the button, and then we need a negative line here. Let's connect it to the top so we can see it better. And then over here is, let's say, pin number 8 right beside 9, so like this. And then now we need to select our pin, so pin mode 8 is input, but don't forget we need a pull-up resistor, so let's include a pull-up. We talked about how the pull-up resistor works before in, I think, 2 previous videos, so you can refer back to those if you're unsure how it works. And then since it's random, we need a variable for the random, so let's say ran, short for random. And then let's print out our random number every single time we select a new number. So over here we can set up a serial manager at 9600 like this. And then in the loop section, we no longer need for loops, but we can include a if statement. So we can read the digital pin for number 8, and then if this is off, so that means the button is pressed, then we can create a random number with the random function and from 0 to 180 degrees. And then we can set our servo arm to that degrees, so right and then random like this. And then we can print our random number in our serial manager and then wait for, let's say, 30 milliseconds like this. Alright, and let's run this. I think this should be it. No mistakes in our code, I believe. Alright, so let's make sure. Oh, of course there's a mistake. Let's see where it is. Oh, I forgot a semicolon here, of course. Oh, we forgot to connect the board now. Alright, now it should work. So let's include everything in our screen. Let's do this. Alright, so every single button press, it should go to a different position. Oh yeah, and let's open our serial monitor. Alright, so now that we see a problem. Every single time I press the button, after the delay, it goes back to the loop and creates another random number. So I just tapped it once, but to the Uno board, it seems like it looped through the code 4 times. So we need to add something else here, something to stop it until we lift our finger up. We can make a delay of 25 seconds. So this is for any like variation in between the electrical flow for the button right after we press it, and then a while loop. So while the digital read for 8 like this, and then delay another 25 seconds. This is for when we let go. So this sees that, so this is if our hand is pressed on the button, then this part will remain true, and then it will keep on looping. But if we let go, then it will turn into false and delay 25 seconds and start the loop again. So this should be a little better. So let's clear this, and then now we can run it again. Alright, so it goes to 67 degrees. And then now it goes to 169 degrees, 113, 38, 130, 152. Our button is kind of not working right now. Alright, now it works. So 24. So we can see our code works. And this is a very good implementation of a servo, a button, and the random. So let's include our code in our document. So this is the code here, and then the homework for today's lesson should be to, let's say, film the servo motor rotating from 0 degrees to 180 degrees. So we can see on here it goes from 0 degrees and then rotates all the way to 180 degrees. Alright, that should be it for this video. Thank you for watching and see you next lesson.